In the last video, we talked about thermal quantities and all the formulas that are related to it. In today's video, let's talk about, let's try and solve some sums. So we have our first question. A brick wall of 19 centimeter thick has a thermal conductivity of 0.811 watt per meter degree Celsius. The outside and the inside surface conductance of the wall are 16 watt per meter square degree Celsius and 8 watt per meter square degree Celsius. The U value of the wall is, so we have to find the U value. But before that, let's jot down the given parameters here. So we have length, which is the thickness. So it is 19 centimeter and you convert it to meters. So you have 19 meter. Then they have given the thermal conductivity of the wall. So they have given us their K, which is 0.811 watt per meter degree Celsius. And they have given us the surface conductance of the outer and inner wall. So our surface conductance of the outer surface is 16 watt per meter square degree Celsius, and the surface conductance of the inner surface is 8 watt per meter square degree Celsius. They are asking us to find the U value. Okay. Now, what is the formula that we know? U value is not additive nature, so we have to add it separately. So you have 1 by U is equal to 1 by surface conductance of the outer surface plus 1 by U1 of the first layer plus so on, and lastly 1 by surface conductance of the inner surface. This is the formula that we use. Now here they have given SC0 to be 16, and we have the SCI, which is the surface conductance of the inner layer, to be 8, and we have to find the U value of the total wall. And how would we find this 1 by U1 of the brick wall alone? That we can find it using these two given equation. So we know that U is equal to K by L. So therefore 1 by U would be L by K, which is nothing but 0.19 by 0.811. Okay, so now let's equate all the given parameters into the equation and we'll find the U. Sorry, we won't find the U, we'll find 1 by U. So 1 by U is equal to 1 by 16 plus 0.19 plus 0.811 plus 1 by 8. Now 1 by 16 is 0.0625 plus, if you divide these two, you'll get 0.2342 plus 0.125, and when you add everything, you'll get 1 by U is equal to 0.4217. Then what is your U value? Your U value is the reciprocal of this. So it is 1 by 0.4217, which will give you 2.37 watt per meter square degree Celsius. So the U value of the wall is 2.37 watt per meter square degree Celsius. So let's write it here. A lot of people would, stop it here and think that's their answer, and that would lead to, you not getting the mark for the question. So always remember to find the reciprocal of the 1 by U, which is your thermal transmittance to your thermal, your thermal resistance to your thermal transmittance. Now let's move on to the next question. So let's see here. A room they have given the dimensions of the room, has 4 230 mm thick wall, external walls. Okay, total wall fenestration is, they have given the area of fenestration 10 meter square, and the temperature difference between the indoor and the outdoor is 2 degrees Celsius. Air to air transmittant values for the 230 mm thick brick wall and the 200 mm thick aerated concrete block wall is 2.4 and 1.7 watt per square meter degree Celsius. If the brick wall are replaced by the aerated blocks, the change in conductivity heat flow is. So they want us to find the difference in the conductivity heat flow when they change the material from brick to aerated blocks. Now let's try to find the heat gain of each material, and then we'll find the difference. Now first, before that, let's jot down the given in the question. So room is of measurement 5 into 5 into 3. And the thickness of the wall is 230 mm, which is 0.23 meter. And they have given us the area of the fenestration is 10 square meter. So they have given us the temperature difference between the indoor and the outdoor is 2 degrees Celsius, which is your delta T. So delta T is 2 degrees Celsius. And they have given us the U value of both the materials. So they have given us the U value of the brick wall is 2.4 watt per square meter degree Celsius, and U value of the aerated blocks is 1.7 watt per meter square degree Celsius. So these all are given in the question, and let's find out the heat gain of each material. So what is the heat gain for formula base? First let's write the heat gain formula. Q is equal to U into A into delta T. This is our formula. Find the area. Area of the wall would be, they have given the measurement as, this is your length, breadth and your height. Okay, so you have two sides of each. So 2 into 5 into 3 plus 2 into 5 into 3 minus the area of the fenestration. So if you calculate, you'll get your area to be 50 square meter. That's it, we have everything. Now we have to submit. Let's find the heat gain of the brick wall. So QB is equal to U into UB into area into delta T, which gives you your UB is 2.4. So 2.4 into 50 into delta T is 2 degrees Celsius. So you'll have the heat gain of the brick wall to be 240 watt. Okay, now let's find the U value of the aerated blocks. So you'll have 1.7 into 50 into 2, which will give you 170 watts. And they have asked us to find the change in conductive heat if the brick wall is replaced by the aerated block. So they basically want us to find the difference between these two, which gives you $70 watt. So 70 watt is the change in the conductive heat flow if the brick wall is replaced by the aerated block. Now let's move on to our next question. So here they have given the section of a wall which has 100 mm brickwork with a 50 mm cavity in the middle and 10 mm plaster on either side. And they have given us some uh, related given parameters here, like the thermal conductivity, which is your K. So they have given your K, and they have given the surface conductance, so they have given SCs, and they have given thermal resistance, which is your R value. And whenever we use a multi-layer so multi-layer, we have to find the U value of a multi-layer component. What do? You find the thermal resistance of it, and then finally invert it to find the U value of that component. So let's do the same. So we know that 1 by U is equal to 1 by SC naught plus 1 by U1 plus 1 by U2 plus 1 by U3 plus 1 by U4 plus 1 by U5 plus 1 by SCI. And here your U1 is this layer, U2 is this, U3 is the cavity, and again U4, and finally U5. Okay, and let's substitute the formulas now. We know 1 by U is basically L by K, and we know the L that is given in the diagram. We know K of the brick wall and the plastering, and for the cavity they have given directly thermal resistance. So your U3 is already given, so we can directly write it as R3 then. Okay, so let's try to solve the formula now. 1 by SE naught, which is external surface conductance, is 9.5. So 1 by 9.5 plus 1 by U1. U1 is your L1 by K1. So what is L1 here? L1 is 10 mm, which is 0.01 meters. So 0.01 by K1. What is the thermal conductivity of the plastering? It's 0.5. So plus 0.5. Now U2. U2 is for the brickwork. Brickwork is 100 mm. So it's 0.1 in meters. So 0.1 by, what is the thermal conductivity of the brick wall? It's 1.2 meters. So you'll have 1.2. And plus, for R3, the cavity, they have given the thermal resistance directly. So we'll just put it directly. So it is here, it's mentioned 0.17. So 0.17 plus again the brick wall, which is your 0.1 by 1.2. And again your plaster, which is 0.01 by 0.5. And lastly, it's your thermal surface conductance of the interior surface, which is your 0.8. So 1 by 8. Okay. Now let's try to find the answer for this. So your 1 by U is equal to when you add everything, you'll get your 1 by U to be 0.6071, and then you have to find the U value. So your U value would be 1 by 0.6071, which is 1.6475 watt per meter square degree Celsius is the U value of the surface. Okay, I hope this is clear again. And now let's move on to the next sum. Okay, if a roof is treated with a layer of thermal insulation material, the internal heat gain is reduced by 60%. Okay, the U value of the roof slab without thermal insulation is 3 watt per square meter degree Celsius. Assuming a constant temperature difference between the indoor and the outdoor, the U value of the insulation layer is. Okay, let's break down this now. So they are saying if they're saying that if the roof is treated with a thermal insulation material, then the heat that is gained, which is basically your heat gain, it is reduced by 60%. So the Q value after insulation is reduced by 60%. This is the first line of the question. Then they have given us the U value without insulation, which is 3 watt per square meter degree Celsius. Now let us consider the roof layer without any insulation. So your Q would be U into A into delta T, right? And we know U, we don't know about the area and we don't know the temperature difference. So we'll just put it as such. So let's put Q is equal to, and this is without insulation. So without insulation, Q is equal to 3 into A into delta T. Okay, and let's keep this equation as equation number 1. And we know that when after insulation, the heat gain, which is the Q, is reduced by 60%, which means it is still 40% of the original heat. Okay, so your Q after insulation would be 40% of the Q without insulation, right? Now let's put it to the formula. So your Qi can be written as 40% of 3 into A into delta T. Like I'm implementing it here, so that is how you'll get it. And 40% you can write it as 0.4 into 3 into A into delta T, which is nothing but, let's just write it as 1.2 into A into delta T. Okay, so this is the insulation. Now let's write it as our equation 2, but without considering anything. If I ask you what is the heat gain of the roof after the insulation, your formula would be U value of the insulation into area into delta T, right? Now let's keep this as our equation 3 and let's equate 2 and 3. So what you would get, since both the left hand side is similar, you'll write it as 1.2 into area into delta T is equal to U value of the insulation into area into delta T. And with this you can solve and you get U value of the insulated roof to be 1.2 watt per meter square degree Celsius. But here comes the tricky part. So they have asked us to find the U value of the insulation alone. This U value is the U value of the roof which is insulated. So it's a component. So it has the U value of the roof alone. It has the U value of the layer, insulation layer as well, right? So okay, let me draw it here. So basically this is your roof, and above this is your insulation layer. Now we know the roof U value is 3 watt per square meter degree Celsius, and we know this entire layer's U value is 1.2 watt per meter square degree Celsius. But they have asked us to find the U value of the thermal insulation layer alone. So they basically asked us to find this layer alone. So what do? We have to find that alone, u value of the and let's name this as our u2. Okay, sorry, u2, and we can write your u value of the insulated surface would be equal to u value without thermal resistance. Since we know that u value is not additive, again we have to use the reverse way. So the thermal resistance of the insulated roof would be equal to the thermal resistance of the roof without insulation and the thermal resistance of the insulation layer. So 1 by u2. Okay, and we know the value for this, and we have to find this basically. So thermal layer of the insulated roof is 1.2. Oh, we can't write it 1.2 directly. So 1 by 1.2 is equal to 1 by 3 plus 1 by u2. And you will get 1 by u2 is equal to minus 1 by 3, which will give you 0.5. So what would be your u2? It would be 2 watt per meter square degree Celsius. This is the u value of the insulation layer. So I hope again this is clear. First, I'll go through this question again. So first they have mentioned us that after insulation, the heat gain is reduced by 60%, which means still 40% of the original heat gain is admitted into the building. So that is our first given condition. Then we know that u value without the insulation was 3 watt per square meter degree Celsius, which was also given in the question. Then we just put it into the formula. So you find the u value of the roof without the insulation, which will give you 3 into A into delta T. And then you find after insulation, which will give you 40% of the original without insulation roof. So that will give you 1.2 into A into delta T. And with equating everything, you will find the u value of the insulated roof, which would give you 1.2 watt per square meter degree Celsius. And this 1.2 watt per degree Celsius is basically of the insulated roof, which means the roof slab plus the insulation layer. But here they've asked us to find the insulation layer layers u value alone. So what do? We again put it to the formula of the thermal resistance formula, and we try to find the u value of the layer alone, which gives you 2 watt per square meter degree Celsius. Now let's move on to the next sum. They have asked us to find the R value here in the first question, but let's jot down the points that are mentioned in the question now. They have given us the resistivity. So an unplastered brickwork has a resistivity of 0.83 meter degree Celsius per watt. So what is resistivity? Resistivity is 1 by K. So this is 0.83 meter degree Celsius per watt. And they have given us the thickness of the wall. So 230 mm thick. So which is L is equal to 230 mm, which is 0.23 meters. And they have given the inside and outside surface resistance. So surface resistance is same, like similarly we talked about surface conductance. So here you need not put it as 1 by SC naught or 1 by SCI. You can just put surface resistance directly. So your surface resistance of the outside temperature is outside surface is 0.1 meter square degree Celsius per watt, and the surface resistance of the inner surface is 0.123 meter square degree Celsius per watt. Here you have 1 by k. Let's find our k, which should be 1 by 0.83, which will give you 1.2049. Okay, now let's find the R value. So what is the formula for R value? R value is additive nature. So you'll just add the surface resistance of the outer surface plus R1 plus so on, and lastly surface resistance of the inner surface. And here they have mentioned both the surface resistance of the internal and the outer surface, so that you can add directly. For the layer of the brick wall alone, we have to do it in the 1 by u way. Okay, so let's do it. R can be also written as 1 by u, and we know our SC0 is 0.1 plus R1. R1 is basically L by K. So which should be, what is L? L is 0.23, and our K we found out to be 1.2049 plus surface resistance of the internal layer, which is 0.123. And when you solve everything, you'll get, let me do it. So this is the R value. And remember, they have asked us the R value. They did not ask us the U value. So you have to stop the, stop solving it here itself and write it as the R value. If they asked us to find the U value, then you reciprocate it and you find the U value of it. Now let's move on to the second part of the question. Okay, they have given us the brick wall as an overall dimension of 6 into 3 meter with a 1 into 2 meter window, and they have given its U value, and a 1 into 2.1 meter door, and they have given its U value as well. They have asked us to find the overall U value. So this becomes our multi-surface question. So what does this mean? So this is your wall, 6 meter into 3 meter, and they have a door which is 2.1 into 1 meter, and they have given a window of 1 into 2. So they have a window of 1 into, and they've asked us to find the U value of the overall surface. Now we know the formula for a multi-surface component, and the way to find the U value would be U1 into A1 plus U2 into A2 plus U3 into A3 by A1 plus A2 plus A3. Right? Now let's find the U value by constituting this formula. So firstly, we have to find the area of each surface. So the area of the door is 1 into 2.1. So you have 2.1 square meter. Area of the window is equal to 1 into 2. So 2 meter. And area of the wall would be 6 into 3 minus 2.1 plus 2, because I've talked about this in the last video as well. You have to find the area of the wall excluding other components like the window and the door. So this area alone we have to find out. Now let's go back. So your area of the wall would be 6 13.9 square meter. And they have given us the U value for the door. So your UD is 1.25. U value of the window is 2.5, and we have found the R value of the wall here. So what would be the U value then? So U value of the wall would be 1 by 0.4138, which would give you 2.4167. So we have all the given, we found all the components of the formula. Let's just put it to it. So U value of the overall surface would be U value of the wall into area of the wall plus U value of the window into area of the window plus U value of the door into area of the door divided by area of the wall plus area of the window plus area of the door. So the U value of the wall is 2.4167 into area of the wall is 13.9 plus window is 2.5 into 2 plus 2.1 into 1.25 divided by 13.9 plus 2 plus 2.1. So you will find the U value to be 2.289 watt per meter square degree Celsius. So this is the U value of the overall surface. Okay, now let's move on to the next sum. They have given us let's read it first. The maximum and the minimum indoor dry bulb temperature of a room are 38 degrees Celsius and 34 degrees Celsius. If the maximum and minimum outdoor dry bulb temperature are 42 degrees Celsius and 30 degrees Celsius, then the thermal damping is, they've asked us to find the thermal damping. Now we know the formula for thermal damping is outside temperature range minus inside temperature range divided by the outside temperature range into 100 because it is expressed in percentage. Now let's find out the temperature ranges of inside and outside, and they have given us as dry bulb temperature, which is same as your air temperature. So what is the range of outside temperature? So outside temperature of 40 and 30. So 42 minus 30, their outside temperature range is 12 degrees Celsius. And let's solve the same for inner. Inner they have given 38 and 34. So 38 minus 34, you'll get 4 degrees Celsius. So what is thermal damping now? Is equal to 12 minus 4 by 12 into 100, and you'll get 8 by 12 into 100. So you'll get 66.67% is the thermal damping. Okay, I hope this is clear. Now let's move on to our last sum, and this sum is based on the horizontal shading device that we talked about. So they've given us a 1.2 meter high window is located on the south facing wall. The solar azimuth angle is equal to the wall azimuth angle. and the solar altitude angle is 60 degrees. And they asked us to find the length of the overhang. Okay, so I'll just draw it here. So this is your window and its height is given as 1.2 meter. And they've asked us to find the height of the overhang. This we have to find. Okay, now we know the formula for finding the horizontal shading device, which is L is equal to H by tan epsilon. Epsilon is the angle that we, this is your epsilon, and epsilon is your vertical shading angle, vertical shadow angle. And what is tan epsilon? Tan epsilon can be written as tan gamma by cos delta. And what is gamma? Gamma is the altitude angle. Okay, so this gamma is your altitude angle, which is given in the question as 60 degree. And your delta is the horizontal shadow angle. Which can be written as azimuth angle of the sun minus azimuth angle of the wall. And they have mentioned that the solar azimuth angle is equal to the azimuth angle of the wall, which means this would become 0. So your delta is 0. So what is your tan epsilon? Tan epsilon becomes tan 60 degree by cos 0 degrees, right? And tan 60 is root 3 and cos 0 is 1. Okay, so your tan epsilon is equal to root 3. Now let's substitute it in this formula and we'll find the length of the horizontal shading device. So your L is equal to H by tan epsilon, and they have given the H to be 1.2 meter, which is the height of the window. So 1.2 by root 3, and if you solve it, you'll have 0.693 meter, which is the depth or length of the overhang or horizontal shading device. And this is the last sum. I hope everything is clear.